please unmute yourself.
Thank you. I didn't think we'd have any technical difficulties today. But why build a framework instead of an app? The concept is build once, use many. And I was really excited when Ross in his keynote mentioned the TIL framework as a framework as opposed to just an app, a shiny app. So in 10 minutes, I'm going to try and get a concept across. It's going to be very challenging, but please reach out to me during the conference. Happy to set up a session, do any chat about this to go through some more. Before we start, the most important slide of any talk, I just want to acknowledge Andrew, Tina, and Chi, who I worked with on this. And I always like to get it in first, just in case we run out of time. So what do we mean by a framework? In the context that I'm going to cover, in a way, it's akin to meta programming. It's code that's building code. And why should you consider a framework? Well, we build lots of shiny apps, and they tend to be reusable to a degree. For example, if we want to change the data, we can put in new data. But what if we want to change the way that the data are processed or the way that the data are displayed? A framework approach provides a reusable architecture that can be utilized for the current and for future projects. Before I really get into this, I want to introduce a framework that I'm going to be using to illustrate the concepts. This is something called a question-based approach, or QBA, and it's a communication tool that we've been developing for a few years. And whereas most Shiny apps have a really high level of interactivity, wanted something that could be used for communication, for statisticians to communicate with clinicians. Clinicians often don't have a lot of time to work with a highly interactive, more exploratory app. They want answers to questions, and that's the concept that, or that's what this provides. Now, generally, as an app developer, you're considering the consumer, the person who's going to utilize the app. But in this case, we've got a third type of person, and that's someone who sits between the developer and the consumer. They're the expert. I look at them as, I call them the knowledge owner. In this case, it's the statistician. The statistician has the expertise of the knowledge, not necessarily the expertise to build the app, to display the knowledge. But if we've got a framework, we can then give them the tools to be able to do this. They don't have to be versed in Shiny. They don't even have to be versed in R to be able to create something spectacular. Framework that I'm talking about here is currently being used in 4 projects in 4 different ways. One of which has a huge amount of data passing through it. So how does the concept work? It's very simple. What we want to do is to encode what we want into a set of human readable instructions, essentially a recipe or a set of steps along with some parameters. And then we'd have a universal interpreter that can translate our instructions into an output. Now, our interpreter is smart. It can build reactivity, meaning that the person who works on creating instructions, for example, doesn't need to know R, doesn't need to know Shiny. It's extensible. It can be extended in lots of different ways. And it's a Shiny module. And in fact, what I will emphasize is that everything is a Shiny module. Almost everything I'll be talking about is a Shiny module. Now, interpreter is intelligent. It can read different instructions and respond accordingly. And that's somewhat simple to do, and I hope I'll show you from a conceptual level. But we can also build multiple interpreters and have our instructions decide which one to use. This might sound a little abstract at the moment, but I'll be working through an illustrative example of how this works. Before I get to that, I just want to introduce something, separation of tasks, because it's a really key concept. We got a number of packages in this particular framework. I've got them here. They're color coded to show the majority of what's in them, either as functions, Shiny modules, and in one case, it's a Flask API. And these fall into a classic three-layer architecture. And what I mean by this from a computing perspective is that we have a data layer where all our data sits and our interactions with the data. We have an application layer where we do all our data processing. And we have a presentation layer, which is where the results come out. And the important thing is that a layer can only interact with an adjacent one. So our data doesn't go directly to the output. It goes through the application layer that does all the brunt of the work. And something like this means that you can have different people working on different parts, but you can also, in theory, have them sitting on different architectures. So a process that's very time consuming won't affect other parts. Now, our framework takes instructions, interprets them, and generates output. Json is a great way to do this. So in our case, we can pass lots of information: data location, data wrangling, interactivity, functional calls and parameters. In fact, any part of our code can be passed this way. Our knowledge worker who's building these instructions doesn't even need to know JSON. We actually have an app that can be used to build these instructional files through a point-click interface. It's another Shiny app. And this is an example of a question from our QBA app. So here we pass some metadata in the data section. Here we're passing just information on where the data's located, but we could pass information on instructions on data wrangling. We do that in a lot of others. If I move down, in this case, we're generating one output, which is a bar chart. And here there are a number of parameters. We call them plot params, which are the parameters used to generate a chart. But there are also UI parameters, which are parameters specifically related to reactivity and interactivity. And these are instructions to build certain types of interactivity for the output. So this is the app that our framework builds. And once again, this is conceptual representation, because I can't go through all of the code, but I wanted to go through how it's built up. So once again, everything is a Shiny level, is a Shiny module. And in this case, we've got 3 levels in our framework. We've got an app level, which is green, what we call the question level, which is blue, and the content or output level, which is red. We can interact at various different levels, and at the question and content level, we can have as much UI as we want. The question level is at the application layer, so it does all the processing. The content level is at the presentation layer. It receives output and displays it. So this is how something is built. We start with selecting what we call a question, and this can be done lots of different ways. There's a drop down, we've got free text search, we've got graphical representations of the whole of question space where people can click in different areas. Once you selected, our question determines which interpreter to use. In this case, it will generate it goes to work. It generates the framework for a question module. How does it do it? And this is what I really want to get to. It's really simple. We pass the name as part of the instructions, and you just use a do call for the name of the Shiny module, and you send the parameters just as a list. It's exactly the way you'd call a Shiny module, but you're using a do call because you're passing it as a variable. if we once the data are imported, the interpreter will uh, construct the UI and the outputs, the content. And it's once again, it pulls it all in, and it once the code is really simple. I just want to get this across. It's just a do call statement. You're taking the instructions, you're determining which Shiny module to use and sending that information across. And I know I'm running on time, so I'll go through these a little faster. Um, the final part is to get your question back into the app. And this is, once again, very straightforward. We just have a sortable div so that it gives people an interesting user experience where they can move things around. And to get this in now, you just use an insert UI. You've generated all the content, you've put it all together, and now you just push it in. It goes straight into the app. And this gives a way of generating all kinds of input output in a way that people can interact with it, do lots of other things. So I haven't, I've really just touched on this, but I wanted to give a very brief intro into some of these concepts because I find it really powerful when I'm developing things. There's a lot that I haven't covered. A couple of them are listed here. I would love for people to reach out. I'm in the process of trying to put a lot of this together as a quarto book, but would love to follow up with people if they have any questions throughout the conference. Thanks.